Alright, what is up guys? This is a video that's been requested for quite some time. We're going to be covering buffer overflow, and in particular, Windows buffer overflow. I've covered Linux buffer overflow before on this channel in the past using some of the over-the-wire boxes, particular Narnia. But this is going to be from TryHackMe, and definitely check out this room if you have the premium version of TryHackMe, which I'd highly recommend, only $10 a month. But hopefully we can do this all in one video. This is going to be quite lengthy, so if it gets too lengthy, we might do it in a multi-part thing. But first thing we need to do is, I'd already deployed the VM, the Windows box, and we're going to need to RDP into it. We can do that from our Linux box, which is what we're going to do. By using this X-Free RDP tool, which is a tool that we have. So this is kind of set up specific to this lab, but there's something I'm going to tack onto this command though as well. If I just run it as is, as they gave me the command here, the problem is the screen will be really small, but we can specify the size of the window when it spawns our RDP session. I'm running on a 1440p monitor actually, so this is the size that I'm going to specify. Oh yeah, and another thing to note is you need to do this as a regular user, not the root user. That's just how it is. It won't spawn, it won't work when you're trying to do it as root. So let me rerun this as just my regular standard user here. And so now we have RDP'd into the box, so we can go back to our instructions here. What's also nice is this Tiberius guy that made this room, he has a video walkthrough as well. So if you're watching this and maybe there's something I missed, I didn't cover, you're confused about, you can check that out, and maybe that'll answer your question. Or maybe there's something I explained better. So watch them both if you so choose here. But yeah, basically this first step is this: that we deploy the VM, log in using RDP, which we have done that. So now we get to the real sort of meat and potatoes here of actually doing the buffer overflow. So we're going to be using the immunity debugger here. It's pre-installed on this system here, the immunity. So I can launch that, and what they tell you is basically the file they want you to run is, I believe it is on the desktop. So if I go to users, admin, and then desktop, I'll see vulnerable apps and the OSCP folder, and I'm going to run this OSCP binary in this case. So now I have ran it here, and once I hit this play button here, that's going to start it. Now I know this is extremely small, you probably can't see. I'm going to go ahead and fix that right now by adjusting the font size, which it is under options and then appearance, fonts. I want to bump this up to, let's see here, change 12 should be good. Let's see. There we go. Probably much easier to see now for you guys. But yeah, this little play button here is how we start it. So I did that. So we're going to just verify that we can connect to the system. And it will be on port 1337 as it says here, right? So if I try a netcat, I should be able to see that I can connect to it, right? So I'll do netcat, the IP address, and port 1337. And yep, we are here. So now we are able to, and here's the valid commands: overflow and then value. In this case, we're doing the first exercise, overflow 1. So we're going to try to overflow that function, basically. And so now there's just a little bit of configuration that it wants us to do. There's a thing built into immunity called Mona, which is a Python. There are basically Python scripts that can do a bunch of different, provide a bunch of nice little utilities for us. So we're going to go ahead and set up our command input thing here. Now, this is something that is not required to do a buffer overflow. You don't have to use Mona at all if you don't want to, but it will make things a lot easier. In some areas where it's almost mandatory is when it comes to like when you'll see later as we look for a jump ESP that doesn't have the protections on it that would prevent us from using it. But yeah, you'll see that in a minute. But we're just going to run that. We can basically copy and paste that. And that's just going to set up the working folder under C, working folder here. And so now, once we've gotten the initial setup out of the way, what we're going to do is actually start fuzzing this function to see if we can crash the program. Remember, we're going to fuzz this parameter here, this overflow 1 parameter, right? We're just basically going to create a string. Let me step you through what this is doing, right? Obviously, we tell it what IP, we tell it what port. We're gonna wait 5 seconds in between each time sending it, just so we can make sure that the server gets the data and is able to process it. We're not spamming it, right? And then we're gonna keep adding on 100 A's every 5 seconds, pretty much indefinitely, okay? We're going to do that indefinitely, right? Basically until the program crashes. And basically when we do crash it, we're going to, get this printed to the screen. We can see that it crashed and how many bytes it crashed at, which is important for the next step, but this is the first step here that we're going to do. So yeah, this was the little prefix string, right? But then here is where we're actually appending it. And we're actually 5 seconds was our timeout. We're only sleeping 1 second in between each time we send this, right? So inside this while loop, we're only sleeping 1 second, and we're going to give it a timeout of 5 seconds. Let me see where set timeout. Okay, yeah. So if we don't get any response for 5 seconds, then that's how we can gauge that. So just to make things a little bit easier, I'm just going to go ahead and copy this. And I could do this in Vim, but I've just been loving VS Code lately, so I'm just going to do this in Visual Studio Code. And I'll just go ahead and open up a terminal here. I'll go to, okay, I'm already here. Let me touch fuzzer.py, we'll call it. And now we got that there, and we'll just paste this in. Looks like that did not copy. Let's try this again. That's weird. I normally do not have copy-paste issues, but I guess that is the curse of doing this live here. Let's see. Let me just try Control-C. Really? Okay, let me try to open up like a regular notepad and paste this in. There, we see we were able to. Copy, paste. Am I not able to copy paste from my VM? Let me try something else here. I am. I had this issue the other day. It's very strange to me. It was only with this example. I don't know. I'm having a little issue here. All right, yeah. So I just went in and manually typed it off camera here just to save you guys some time so you don't have to watch that. But now that we have this here, what we can do is we should be able to run this to fuzz the application. Now every time before I run it, I just verify connectivity with this, and then we saw the banner. That means that we're still able to access the service. So I should have this here. So let's just go ahead and run this, and we can do that by doing Python 3 fuzzer.py. And yeah, we see this here every second. Incrementing, 100 bytes, 100 more bytes each time, and telling you where we're at in the fuzzing. So we're just going to let this thing run until we overflow the buffer and thus crash the application. So this is always like the first step in buffer overflows. It's just identifying if there's a buffer overflow potential vulnerability to begin with, right? Now we see it kind of hang here, and Yep, after the timeout of 5 seconds, we see that it did crash at 2,000 bytes. So now we can go back here. And this will walk you through all of this. If you don't really understand what to do, you can read this and it'll tell you step by step. And there's also another video by that Tiberius guy that'll also walk you through this. But that's why we do what we do here. And it says make note of the largest number of bytes that were sent. That's why we saw that 2,000 bytes there. And now the cool thing about the scripts that it gives you here, you can actually just save these on your computer as like your placeholder scripts, and then you can just modify them, tweak them as you need for whatever application you're working with. But for the most part, especially this script right here, can serve as an excellent template when you're doing these buffer overflows, just to save you time and allow you to be a lot more efficient. So after we identify that we're able to crash it, now we want to see, can we control EIP, the extended instruction pointer? And what that is basically just a CPU register that tells the application, or tells the CPU, basically, not the application, but the actual CPU. It tells it what needs to get executed next. So basically, as the name suggests, it just points it in the direction of the next instruction. So if we can control that, we can tell it what to do next. We can tell it to jump on over to our malicious code. That is the ultimate goal here, and then connect back to our listener, right? And so the very next thing we want to do is see, can we control what goes into this register? So the way that you pretty much do that is use pattern create, this tool right here, and you pass in the length of the however many bytes it took to crash the server, right? In our case, 2,000. So we're going to change this 600 to 2,000. So let's do that. And what it's going to do is it's going to generate a random string, a string of like random characters here without any duplicates or anything, that is 2,000 characters long. And so we can actually take this and put it into the script, right? So I'm going to go ahead and create another file. I'll name it what they name it, just to avoid any confusion here. What are they calling this one? Or I think they're actually using this for the fuzzer.py now, which is fine. So we can do the same thing. We'll follow suit. And this one did copy and paste nicely. I don't know what was going on with that first one, but this one did work and play nicely here. So you see all these placeholders. That's what is so good about using this script as a template. I think from now on, I'm going to use this one, even when I'm on OSCP or whatever. But what we're going to do is we're going to put that unique string into the payload variable. Oops. Into the payload variable. Let me recopy that. And try this again. And so now we have that there. So we go back here. And now we should be able to run this again. Actually, they did call it exploit.py. So I stand corrected here. Well, we'll just rename this really quick. So if we just do a move on fuzzer.py, we'll do a move, fine. Move fuzzer.py to exploit.py. And of course, that's going to make this say deleted, so reopen it here. And now we can go ahead and run this little exploit script here. I'll clear the screen. And we're just going to do... Oh, yeah. One thing that I almost forgot, I very nearly forgot, is every time you run one of these, you're going to have to reattach the process and restart it, because we crashed the program, right? So the program's not running. So if we tried to do the netcat thing to connect to it, we wouldn't be able to connect, right? Because it's not actually running. We crashed the program before, and we didn't restart it after. So every time you're going to have to reopen it here and hit the little play button so that it's working. And now what we'll see is, we get the banner. It's working fine. So we'll go ahead and run this exploit script. And you see all this stuff change here. That means we actually did crash the program. And you can see this is like what's in our EIP register, which is part of our script, as we'll see in a moment. So we are in fact able to control EIP. So there's different ways to do this. There's another Metasploit tools script you can use called pattern offset.rb, but the way they're teaching it here is you can actually do the same thing in Mona, apparently. So if I copy this, but pass it 2000 instead of 600, we'll see, we can see that here. Because remember, we had 2000 bytes to crash the thing. So then once you do that, it actually will tell you what the offset is. So the offset is actually this first one up here where EIP is, right? That's what we care about, right? We don't really care about controlling these other registers. We care about controlling EIP. And to do that, we need to pass it 1978 bytes of data. So with that info, what we can now do is go back to our script here, and we can say that the offset is 1978. Okay? And see, this is why this is such a nice template. So now all we have to do is say this is the offset, and what it's going to do is actually pad that offset with that many A's, right? And now we can go into the return address here and pass it 4 B's. And what we should see in the EIP register when we run this is we should actually see, let me delete this, right? We should actually see 42, 42, 42, 42, because 42 is the ASCII hexadecimal representation of the capital B ASCII value, okay? So basically what I'm saying is, when it comes to ASCII, ASCII is like all the characters that you see on your keyboard pretty much, right? They all correspond to a different hexadecimal value, and for the capital letter B, I just happen to know that as being 42, okay? So that's what's going on there. So if we rerun this, right, reopen, play, and I always like to verify connectivity, making sure I see the banner, and we're good to go. And we need to save this so the changes go through. Then we should be able to run this again. And now there you go. You see EIP, 42, 42, 42, 42, just like we predicted there. And so now we know that going forward, instead of just putting a bunch of B's in here, we can put the return address to a jump ESP call and then put our malicious code in. That will be something for next time. This video is getting kind of long, but this is a great way to get started. Check out TryHackMe, guys, if you haven't already. These scripts are super handy, right? I mean, you could code this all yourself. It's not a lot of code at all, but it's nice to have a template like this, right? We basically just have like a value called offset that we can, it's just smart the way they code it, right? So all we have to do is change the offset. If we're working with a different buffer overflow machine, right, a different program, and say it took 3,000 bytes to crash the application, well, we can just put 3,000 or 2,000 whatever as our offset, and then it'll do that for us, right? And this is our return address, and basically it'll put the return address where it needs to go, right here. And so it wouldn't be too hard to figure this out yourself. You don't have to have TryHackMe for this. Obviously, you can figure this out yourself. It's not too tricky. But even if you don't use TryHackMe, right, create your, a lot of these buffer overflows are going to be very similar. There's certain things you're going to need to tweak. Create your template, right? Create your template script. Something like this, or whatever you like to work with, right? And then something that's easy to modify for the future for different applications that you come across. It's just going to save you time. Remember, it's all about being efficient with the OSCP, because that will give you more time to actually root the boxes that you need to root, which is all of them. So, but yeah, hopefully this video was of help to you guys. In the next one, we're going to be, finding the bad characters, identifying our jump ESP in the application that we're able to use, that it doesn't have any DEP, ASLR, all that. And we're just going to generate a payload, pad it with some no ops, and go ahead and grab our shell. So if that sounds interesting to you, be sure to subscribe to the channel and hit the like button to really help get this video out there to people that might be struggling with some buffer overflows. And stay tuned for the part 2 to this video. I will see you guys in the next one. Thanks for watching.